Okay, so in these problems, we're just graphing these inequalities. If you have to make your own number line, I usually suggest to my students making sure that you put at least 2 points on each side of it. So all of my graphs are going to have 2 points on each side. Make sure when you're dealing with negatives that you count down on the negatives, so the more negative on the left, the less negative on the right. You always make sure you pay attention to the inequality sign to find out if it's equal to or not equal to. So this is not equal to, so that's an open circle, because -5 is not a part of our solution. If we were to close in the circle, then that would be telling us it is part of our solution. And then now all we do is we look for the side of the -5 that has things that are greater than -5. Well, -7 is not greater than -5, but -4 is. And so we shade in the right side. And we always shade the arrow in to let us know that it goes on forever, because this is all of the numbers greater than -5 are the answer. So for the 16, if you put in your number line, put 24 in the middle, and then you can just put 2 numbers on each side. It's an equal to, so we're going to put a closed circle there on 24. And then it's less than, so we're going to move, we're going to shade to the left, because 22, 23, those are numbers that are less than 24. So they are solutions to this inequality. Anything to the right of 24 would be greater than that, and that would not be a solution to this inequality. 17, 18, and 19 are complex inequalities. Remember, OR inequalities mean only one of the 2 inequalities has to be satisfied for it to be a solution. So they're very simple. All you need to do on those is graph the 2 inequalities separate from each other. So we're going to put -5, -4, -3, and then go all the way to 4. So this is going to be a pretty big number line. Okay, our cutoff points, we've got an open circle at 4 because it's not equal to, and a closed circle at -3 because it is equal to. We're looking for the numbers greater than 4. Well, those will go over here to the right. Those are numbers greater than 4, or numbers less than -3. And so you can shade in both of these because it's an OR inequality. And OR inequalities always have both of them shaded in. And inequalities means you have to satisfy both inequality. I'm going to do 19 first because it's a direct and inequality. And so when you do this, we've got open circles at a 5 and an 8 because they're not equal to. And we're looking at x greater than 5. So the numbers greater than 5 are numbers to the right. 6, 7, 8, 9, 10. Those are all greater than 5. But numbers less than 8 are numbers to the left. And so if I pick one of these, like for instance 3, well, 3 does not make this true. And so is 3 greater than 5 and less than 8? No. So it's not a solution. It's got to be the numbers in between. Now, I will say as a math teacher, probably 95% of the time, an OR inequality looks like this, and an AND inequality looks like that. OR inequalities go away from each other, and inequalities are usually between the 2 cutoff points. 18 is actually also an AND inequality whenever you see something like this. It reads x is greater than -12 and x is less than -8. So you just plug in your numbers, you know, get -12 and -8 are your cutoffs. I'm having trouble writing them out. And so you get a closed circle at -8, closed circle at -12, and then it's just the things in between. Okay, the last couple here, remember at least -3. At least is always greater than or equal to, because at least means the smallest it can be is -3, or it can be bigger than that. So it's going to be x greater than or equal to -3, or whatever variable you want the number to be. I'm not going to graph these for time's sake. X is no more than x. You got to think about what does it mean to be no more than. It can't be more than x, but it can be less than x. Or 5 is no more than x, and so 5 can't be more than x, but it can be equal to x or less than x, so it's going to look like this. 5 less than or equal to x, or you can flip it around and make it x greater than or equal to 5. Is probably the best way to graph that, and make sure you get a graph left. Better. And then 22, x is less than 4 and is more than 1. So this is an and inequality. So you have x less than 4 and x is more than or greater than 1. And so that would be what it is, and you have to have the and inequality to let us know that that's what's called a conjunction.